We're going to continue on with graphing one-to-one functions and graphing its inverse on the same graph. But now we're actually going to be able to name that inverse function using these 4 steps right here. Now, before we get to this, I want to do part of this problem on example 5. So example 5 says find the inverse of f of x equals 2x minus 2, and we want to graph the function and its inverse on the same coordinate axis. So let's start by graphing our f of x. So this is my y equals mx plus b. This 2 right here represents my slope. And this -2 is my y-intercept. So starting at -2 on my y-intercept, now I'm going to use my slope, which is up 2 over 1, since that's the same as 2 over 1, right? So rise 2, run the right 1. We need a positive slope here. And I'm going to do that the entire way. And now I'm going to go back the opposite way. So down 2 to the left 1. Right there. Here is my graph. And because we're going to use this graph for more than one function, we need to label it. So I'm going to label this as f, my original function. So now we need to find the inverse and then put that graph on here. Now, before we find this function, we could do what we did in last video and just write down all of these ordered pairs and switch them. But this one's not too bad to graph by hand. So we're going to do these steps here. So the first step is to replace f of x with y. So instead of this being f of x equals, now I have y equals 2x minus 2. The second thing we need to do is interchange. Interchange x and y. So where I see a y, I'm writing an x. And where I see an x, I am writing a y. Step 3 is to solve for y. So now I need to get this y by itself. So to do that, we're going to add that 2 over. And then divide by 2. And what am I going to divide by 2 over here on the left side? Hopefully you didn't get tricked by my trick question. We're going to divide everything. So 1 over 2 is 1/2 x. 2 over 2 is plus 1, and now equals y. So many times you guys stop right here, but we still have another step. The last step is to replace y back into your function notation with its inverse notation. So with the inverse of f of x. So we have the inverse of f of x equals 1/2 x plus 1. Okay, with this, my slope is 1/2 and my y-intercept is 1. So I'm going to start at 1 and I'm going to rise 1, run 2, positive direction. Now I want to go the opposite way. So I'll go down 1 to the left 2. And so we can see here that even though these are inverses of each other, they both have a positive slope. So it does not mean one's positive and one's negative. Okay, and there is my inverse function. And so I will label that as f to the -1 representing the inverse. Now it's kind of hard to see graphically that these are inverses of each other. So I'm actually going to take it one more step further and put in that line of symmetry, which we said on the previous page, on the previous video, that the line of symmetry is y equals x. So I want to draw a line. I'm going to go ahead and do a dashed line because this is just for visual purposes. A dashed line through the origin from corner to corner. This is my line of symmetry. And this is y equals x. So when we draw that in, we can visually see a little bit better how it is symmetric, right? If you turn it that way, you can see it's equal distance from that line everywhere you go. Now, along with this, we need to verify that these are inverses. If you're taking this class on campus, this is a test question. So don't just hit the yes, because it's going to say, did you verify? And you're just going to click yes. But then when you come to this on your test, you're not going to know how to do it. So don't skip this, go through the process. This is from last lesson. It says to verify that the inverse is the inverse of your function, find that the inverse of f of x equals x and underlined f of the inverse of x also equals x. So if I rewrite this one over here, we have the inverse of f of x. And so now let's substitute everything in. With these, we start on the inside. So what was my function? My function was this 2x minus 2. And now I need to go to my inverse function and replace this x with what I have in parentheses. So this becomes 1/2 times 2x minus 2 plus 1. So work this out, and we need to get to an x. So if I distribute in this 1/2 times 2x is x. 1/2 times a -2 is -1. Bring down your plus 1. And then these cancel. So we distributed. And these cancel. And I am left with x. You cannot stop there and say we're done because we got x. It has to work this way and this way. That's again why we have underlined it. And so now we will go f of the inverse of x. So starting inside, we have f of 1/2 x plus 1. And now go back into your function and replace this x with what we have in parentheses. So 2 times 1/2 x plus 1 minus 2. We're going to do the same thing. Let's distribute in that 2. So 2 times 1/2 x is x. 2 times 1 is 2. Bring down your minus 2. Plus and minus 2 cancel out, and I am again left with x. So we have verified that these are inverse functions. Let's continue on to our last example. And it says find the inverse of f of x and verify that f and the inverse are inverses of each other. So looking somewhere, just have it right here. At our steps, we're going to follow these steps to find that inverse. So the first thing we're going to do is replace f of x with y. So now this is y equals the cubic root, nope, x cubed plus 5. Now we're going to interchange x and y. So where I see an x becomes a y. Where I see a y, it becomes an x. Step 3, solve for y. So now I need to get this y by itself. So first thing we're going to do is subtract that 5 over. Y is still not by itself. The opposite of y cubed is to take the cubic root. So those are going to cancel, and I am left with the cubic root of x minus 5 equals y. Do not stop there. That's not the last step. The last step is to replace y with your inverse function notation. So the inverse of x is the cubic root of x minus 5. Okay, now we need to verify. All right, so to verify, we need to show that f of the inverse of x and the inverse of f of x. Okay, and hopefully these both end with an x. So starting with this one, replace your f of negative x or your inverse of x to this in here. So we have f of the cubic root of x minus 5. Now we'll come up here to this function and we're going to replace this x with what I have in parentheses. So this is the cubic root of x minus 5 cubed and then plus 5. So here, your cubic root and cube cancel, and we're left with what's under that radical. And now positive and negative 5 cancel, and we're left with x. Now this one, replace what your function was right here. So we'll have the inverse times x cubed plus 5. And now for your function, replace this x with what we have in parentheses. So I have the cubic root of x cubed plus 5, and then bring over your minus 5. So this time what's under the radical simplifies first. So we're left with the cubic root of x cubed, which is under the radical. These still cancel out, and I am left with x. So these are always going to be yes, no questions. I'm pretty sure. Did you verify? Yes. Did you verify? No. Or once you verified, was it inverses or, something like that. Don't always just click yes. Okay. Make sure you can get through this because this will be a test question, especially for my on-campusers. And you can also verify this by using your graph. If I put in my function into my F1, and then in place of F2, I put in my inverse, which to get to the cubic root, we're going to hit math right here. Right here, math. And it's number 4. And I'm going to go zoom 6 for a standard. There are my inverses. Now this looks a little bit off just simply because it's a rectangle, but we can go actually one step further. And in place of y3, we can do our y equals x. And now you can see that a little bit more clearly how it is reflected over that line.